Excellent. Thank you for having me. It was rather impromptu, given that I am substituting for Dr. Hans Breiter, who had an unfortunate accident a couple of weeks ago, in fact, a month ago. Um, we all hope he has a speedy recovery. He's currently in rehabilitation from his injuries. I should also thank Dr. Martin Block for compiling some of the results in Bayesian Lab, as you will see in this presentation. But I must introduce a caveat here. I have not used Bayesian Lab yet, but I have been convinced that I probably should, given the course of the presentations today. And I should also thank the presenters thus far because you have effectively covered everything that I want to talk about. So it's going to make my life substantially easy. So having said this, we're going to talk about unifying frameworks. Okay, so earlier in the day, we had Gabrielle, who was kind enough to introduce us to prospect theory. And I will give you a gentle introduction to prospect theory if you're not familiar with it. It was a revolutionary concept introduced by Danny Kahneman, who passed away last month, along with Amos Tversky. And this was a very important introduction into economic theory. I'm an economist by training, but I'm working in computer science because I believe that there is some form of confluence that can be arrived upon using the behavioral aspects of economic theory and modern computational techniques. So having said that, so prospect theory, which was introduced in 1979, makes a straightforward proposition. Usually, when you're provided with the first statement, what people tend to do is choose the first option instead of the second one. Because the original theory, the original expected utility theory, which was developed by John von Neumann, suggested that rational agents, which are human beings will always choose to maximize the expected value of their returns, meaning that you should always choose the second option because the payoff for choosing the second option is $500. But the payoff for choosing the first option is only $450. But despite this, we notice through experimental conditions, first noticed by Kahneman and Tversky, that people tend to choose. They are more likely to choose the first option instead of the second option. And the same is for the second scenario that you're presented with. So when you are presented with the choice of losing $500 versus a 50% chance of losing $1,100, meaning that your expected loss is $550 here, meaning that it is more than the first option, but yet you choose the second option. So you're in the process of mitigating your losses and you weigh the probabilities radically differently. Even though we are subject to the same probability, the way we perceive that probability is substantially different. This brings us to something as such. So you weight your gain in a concave function form while you weight your losses in a convex functional form, meaning that you can take this example. In March 2020, we had the breakout of the COVID pandemic. We had very less information about the pandemic. So the way people operated under the conditions of the pandemic were predicated on the assumed risk of the pandemic. So when Kurt introduced us to risk being this gravity times probability, the way people perceived that probability was substantially different. Because if I was infected by the disease, that is COVID, I assumed a higher probability of mortality. So, having said that, I would stay indoors a lot more because I am not looking at the data. I am simply perceiving the probability of my risk to be higher than what it is. I mitigate my risk. So, if you're immunocompromised, you tend to spend more time at home because you know that the risk that you're being subjected to is much higher than what the actual risk for the general population is. it similarly operates for the game. The more money you receive, the less likely you are to value that. Okay, they often say your first $1 million are the hardest to earn, after which, well, it's diminishing utility. And that is what we tend to see. And this is the predicate for actual human behavior rather than this rational expectation model, which was conceived and subject to, for the last 50, 60 years, economic theory has still been held by rational expectation and rational agents. So we are slowly moving away towards something that truly defines human behavior, or something that closely approximates human behavior. Given this, we now have the possibility of extracting this information about human preferences and human behavior. And we do so, and Martin was instrumental in constructing this survey. There were 3 major surveys, and in fact, a few more than that, but we're only going to talk about the 3 surveys that were conducted in the course of this experimental setup. People in the survey were provided with pictures such as these. Okay, pictures in specific categories. These are the fluffy, cute animals. Of course, you have the vicious, violent animals. You have appealing food. You have less appealing food. You have other categories as such. You have, I don't know, a scantily clad women on a beach, and you had, I don't know, the opposite spectrum of whatever that might be. So people would then therefore reveal the preferences for the pictures that they see. Okay, they either score it higher or lower. And this gives us information about their own preferences for risk and aversion to the said risk. So if I'm presented with a picture of a shark, I am more likely to be averse to that. So I will rate it on the negative scale. So in that way, I am revealing what my preferences for risk and rewards actually are. There were 3 surveys that were conducted, and the total sample size, the usable sample size, is roughly about 10,000 from all these 3 surveys put together. So we have a relatively rich data set about revealed preferences of human beings, which is rather important. We've not yet had such experiments conducted in the field of economics on a large scale, especially a scale as big as this, with which we've been capable, again, when I say we, our lab has successfully predicted vaccine uptakes and also the possibility of suicide, predicting suicidality. This was a recent paper that was accepted fairly recently. So the information that is encoded in a simple experimental setup, where you're just rating pictures of fluffy kittens and vicious sharks, it gives substantial information about your preference for risk and the aversion to that said risk. Okay, it leads us to something that looks like this. So if you notice, the graph right here is very similar to the original proposition by Kahneman and Tversky right here. But what you do not notice in the original proposition is that there are certain offsets on the x and y axis, on the x-axis, both on the positive and negative side, which we tend to see in the actual compiled data. So there are these tiny offsets on you see the beta plus and the beta minus. You can think of these to be, imagine yourself dropping $5. You're walking on the street, you just drop $5. Everyone's done that before. And you've walked a mile since that point. Do you care enough? Do you care enough to go back and pick up those $5? Probably not. You don't value it as much. But if you drop, let's say, $100, maybe you would go back and search for those $100. So when you're in a situation where you're losing a certain amount of money, for an example, what is the value of the money that would compel you to care? In a similar fashion, assume that you're the person who finds that money on the road. Okay, no moral compunction aside, what is the value of that money such that it'll force you to pick it up and put it in your pocket and walk away? If it's just a couple of bucks, maybe you don't care enough. Maybe if it's 20 bucks, nobody's looking, you put it in your pocket and you walk away because it's valuable enough for you to do that. But this gives us these separations which are not originally seen in the Kahneman-Tversky proposition. So we had this excellent exposition on how factories operate, and we produce toilet paper. That gives us the equation which governs this relationship. It's a Cobb-Douglas production function. Maybe you've heard of it. Maybe you're familiar with it. It effectively says the produced output is a function of land, okay, your warehouses where your 1-ton toilet paper is stored, your capital, which are all the equipment needed to cook the wood pulp and effectively draw those large sheets of paper, and labor, all the people working on the floor to ensure that there is sufficient production happening. Okay, so these factors, all three of them put together, produce the output or govern the possibility of output. We use the same functional form to dictate the relationship between your preference for a picture as such and the value that you place on them. So the value that you place on them is on the vertical axis, the y-axis, and the rating that you've given is on the x-axis. So this gives us 15 variables, as we've mentioned right here. It gives us 15 preference variables which reasonably govern the behavior of people. And now this is rather, it's a bold claim. It's a bold claim to say something as such, that there are just 15 variables that can sufficiently predict your behavior. But given the success that we've had in reasonably predicting some of the profound questions in recent years, it gives us enough reason to believe that these variables are powerful. They're powerful enough to tell us the story about the functioning of the human brain. Okay, where does this lead us to? I'm not going to bog you down with some of these definitions, but you can think of the first set of variables, the 5 variables that are mentioned here. They come from the value function. The value function is described by Kahneman and Tversky. The value function being how much value do you actually place on a possible gain or a possible loss? Okay. What do you perceive it to be? The other set of 6 variables are the strength of this risk. Okay, so how much maximum risk are you willing to take, and how much gain are you going to get from that risk that you're willing to take? In similar fashion, how much risk are you willing to take in order to perhaps take a gamble? Okay, so both on the positive side and the negative side. Both on the positive side, which you can see here, the positive, this concave parabola, which is defining the maximum amount of risk that you're willing to undertake in order to gain something. And the negative or the convex parabola, in this case, is describing the maximum amount of risk you're willing to undertake in order to mitigate some loss. And the final limit function, what this is defining is how you're balancing these two things. Okay, let's say, for example, that I have a preference for Indian food, but I do not have a preference for European food. Am I consistent with these beliefs? Am I consistent in that, okay, if I like Indian food, do I also like Chinese food? Do I also like other Asian food, which is coming from the same vicinity? Am I consistent in my beliefs and preferences for food that are relatively similar? But if I'm flying all over the place, okay, I like the French food, but I hate the German food. If that is the case, I think there is good reason to hate the German food, but Uh, but am I consistent in my beliefs as such? If I like European food, am I keeping to that? And this gives us some strong relationships between the variables. Now, thus far, we have assumed that all these variables are relatively independent, meaning that there is no conditional dependency. Okay? Every project that we've undertaken thus far is under the assumption that the variables are independent. But what we do tend to find, and Martin is the one who managed to do this using Bayesian, he did notice that there are some conditional dependencies among these 15 variables that we have accumulated which govern human behavior. Again, I'm making a very bold claim, so I should step back. So each time I say that, it's just a so take it with a grain of salt. But these variables are fairly powerful. And we notice them across all three data sets, that there are certain variables that are conditionally independent given other sets of variables. And can't necessarily see them, but these color codings, they effectively imply that variables that are related to gains are related, even in the graphs that we do see in the network right here. And variables that govern losses are also clustered here in green. Okay. So this is effectively telling us that the mechanism by which these variables are operating, they tend to be in some form of relationship that we have not yet used so far. So everything that has been presented in this conference thus far is leveraging the techniques available and provided by Bayesian, and using these Bayesian networks to make certain certain predictions. We have not yet leveraged these tools in the studies that we've done so far, but it stands to reason that we probably should. And this is the first time that we've actually discovered that there is perhaps an underlying relationship between the variables that we've just described. We also notice here that the way by which you're avoiding risk is related to the insurance, or the negative offset that you see on that value function. In similar fashion, the total amount of risk that you're willing to take in order to get a gain is related to the positive offset on that value function graph. So we have, and I should thank Gabriel for going through all of this in the morning, so I don't have to regale the same story to you. But the classification approach that we used is a balanced random forest approach. And some of the things that we were able to predict using these are the 15 relative preference variables. And these, some of the things that you see, the PHQ, they're standardized metrics, which effectively ask people about their mental health and other standardized procedures and variables which are collected from patients who are suffering from crippling depression and anxiety. These variables substantially predict, or are reasonable in predicting, as you can see from the AUC ROC, they're reasonably good in predicting planned suicide or suicide planning, which is rather important. We can use a non-invasive technique and get information just through a survey and figure out if the person is going to at least attempt a suicide. And all we need of them is their preferences for risk and their aversion to risk. I must say that I was not part of the experiment and this study, so I'm not entirely sure what planning for safety means. I could give you a good description of what that actually is. But I can tell you that these numbers are reasonably fine. But the unfortunate problem here is that we have not yet leveraged the fact that there is an underlying conditional independence among the 15 relative preference variables that we've just looked at that we've not yet taken advantage of. Maybe when we do a machine learning Bayesian network prediction, perhaps it is going to enhance them more than what we actually do see in these balanced random forest results. That's all I have. Any questions?